All right, so let's do the warm-up first. Then we'll go over any questions you may have on your homework. Now, we just have one example problem today, and then you'll get your homework. You should have some time to work on it in class today. All right, so it says label the x-intercepts, vertex, and axis of symmetry. Also says graph too, right? So the first thing I would do is find the x-intercepts. And that's the easy part of this, isn't it? All right. X-intercept means the y is what? 0, right? And we just look and set these two factors equal to 0. If x plus 2 equals 0, what's x got to be? If I set x plus 2 equal to 0, what's x got to be? Negative 2. If I set x plus 6 equals 0, negative 6. So there's my x-intercepts. Negative 2 and negative 6. All right. Looking at this, does it open up or down? Up. Yeah. Okay. So if we know the two x-intercepts, we can figure out the axis of symmetry because we know our parabola is symmetrical, right? So that axis of symmetry has to be halfway between those two x-intercepts, right? So what is halfway between those two? Negative 4. You guys with us? That makes sense? All right. So we got this. Check. We got these. Check. All right. Now we have to find the vertex. Well, just like we did before with standard form, once we know the x value, our axis of symmetry, what do we do with that value? To find the y value, the vertex. Plug it into the original problem, right? So my vertex, I know is negative 4 something. To find out what that is, I just put my negative 4 in for x in the equation there. So what's negative 4 plus 2? Negative 2. What's negative 4 plus 6? 2. So 3 times negative 2 is negative 6 times 2 is negative 12, right? So my vertex is down here. I need to give myself a little room, it only goes to 10, right? So I'm just going to guesstimate here, say it's right there. Can I draw my parabola now? Yeah, I can draw it, right? Is it opening up? Yeah. Oops, I kind of got it. Just a quick review, this 3 tells us what's happening to that parent function. Cool? It's making it skinnier because it's a vertical stretch, right? A vertical stretch by a factor of 3, so that's why it's skinny. Okay? Does that help on those types of problems? That was the new form. We called that intercept form, right? We have vertex form, we have standard form, and that was intercept form. We can tell what the x-intercepts are by looking at it when it's in that form. Okay? Questions? Homework, you guys have them. Any issues with 18, 19, or 22? 22 might have been tricky. Go ahead, George.
Oh, I don't know, I got like these weird fractions
For 22?
Yeah.
Okay, what's my A for 22?
-6.
It's a positive 6, right? What's my B? Yeah, it's 0, because there's not an X there. And then my C is -5. So that's what's tricky about it. There's no X in the middle there, like we're used to seeing. So that means the B value is 0. Okay? So if we have to graph it, it says label the vertex and the axis of symmetry. Remember, let's find those two things before we graph it, right? So to find my axis of symmetry, it's negative B over 2A, right? What's B? What's B? 0, right? Can I write -0, or do I need to write -0? No. And then 2 times 6 is 12. Well, what's 0 divided by anything? 0. So my axis of symmetry is x equals 0, which is the y axis. So that's our parent function spot, right? What's the y intercept? -5, right? Whatever the c value is, right? So my y-intercept's here. Okay. Does this open up or down? Up. Right? Because my a was +6. So we got to find a point, right? Well, what's an easy point x value to pick? If this is my y-intercept. Either side of that, right? So let's go to the right. What number are we going to use? If I go right, we usually just go by ones, don't we? Yeah, so it's just 1, right? So what's 6 times 1 squared -5? What's 1 squared times 6? So what's 6 minus 5? 1, right? So here's a point, 1, 1. We got to reflect it. So what's another point? -1, 1, right? Is that enough to graph it? What ends up being our vertex? Yeah, this y-intercept ends up being our vertex, doesn't it? Okay. So the vertex is 0, -5. And since we know, if we plug in 0 for x, like we would normally do, 0 squared is 0 times 6 is 0 minus 5 is -5. So there's our parabola. So it's been stretched vertically by a factor of what? Real skinny, right? It moved it down vertically 5 from our parent function. Okay? So that was tricky because the b was 0. But once you realize b is 0, it's not bad, right? Connor, you finished with that? Yes. Can you hand that to me? Nice. All right. Any other questions? 18, 19, or 22? All right. What about 35 or 36? Didn't have to do any graphing. We just had to find the max or minimum value, domain and range, increasing, decreasing stuff. Does it make sense with the ones I did that you're looking at, that you checked? Any questions? Okay. No questions? Then the last two, that's like our warm-up. So we were supposed to graph it, but again, figure out that what x-intercepts the vertex axis symmetry first. Then you can graph it. It's much easier. And again, if we get stuck, what can we always go to see what it looks like? Your graphing calculator, right? You can just put those in your graphing calculator and it'll draw the parabola for you, right? What button you have to push first? Your y equals, right? And then just put it in. Questions? No questions. We're okay. All right. So today we just have one example. It's a word problem. All right. So we're going to have to use some common sense here. You all have that, don't you? No? Of course you do. All right, so the parabola shows the path of your first golf shot. So this picture down here is your first golf shot. All right? And it says where x is the horizontal distance in yards. So how far did it go? 100 yards. You guys with us there? And the y, the corresponding height in yards. So how high did it go? The 25 yards, right? The 50s is, it went at 50 yards away, it was 25 yards high. You guys see that? That's our vertex of our parabola, right? It says the path of your second shot is modeled by this function. Negative 0.02x times x minus 80. Which shot travels farther before hitting the ground? Which travels higher? Okay? So, let's figure out the x-intercepts for this one. This is second shot, right? So, what do we do with, you're welcome. What do we do to find the x-intercepts? What do we do with the two factors? We set them equal to 0, right? So, negative 0.02x equals 0, or x minus 80 equals 0. What do I do to solve this one on the right? Plus 80, right? Well, what's 0 plus 80? 80, right? So one of my x-intercepts is 80. How do I solve for x here? Divide by negative 0.02. What's 0 divided by anything? We already said that? 0. All right. So if I drew that picture of it, a graph of it, 0, 0, and 80, 0, right? Those are my two x-intercepts. You with me? Okay, and then, you hit it, so it went up and down, right? That's pretty good, huh? Nice and smooth. Okay, so where's the axis of symmetry for this? At 40, right? Halfway between, this x value here is 40. So this point is 40 what? How do I figure out that y value? What have we done in the past once we knew the axis of symmetry? Plugged it in, right? For what? For the x, right? So I'm gonna plug in 40 for those two x's and then solve it. All right, so it's like doing f of 40, right? That's basically what we're doing. So negative 0.02 times 40, and then 40 minus 8. So negative 0.02 times 40 times negative 40, right? So let's put that in our calculator. There it is. Negative 0.02 times 40 times negative 40. 32. So this vertex is 40, 32. So let's answer the questions. Which shot travels farther before hitting the ground, first or second? How far did here's the first one. How far did the first one go? 100 yards. How long did the second one go? 80 yards. So the first shot traveled further. Which one traveled higher? Second one. We're looking at, that got to be 25 yards high, but this one got to be 32 yards high. So basically what we did with this equation was figured out the x-intercepts, figured out the axis of symmetry and the vertex, just like last night, some of the homework problems, right? And then we had to look at the problem and answer the question using all that common sense you have. All right, so you're going to have a problem or two like that here also. Questions? Get it? Got it? Good? Look good, feel good? You are good, right? Yes, you are. Cindy, you are good. You're all good. Yes, ma'am. What do they charge you for? All right, so your homework is this worksheet I'm going to pass out to you. You've got about 18 minutes, so you could